Okay, so we're gonna start today, rather continue with the topic that we covered last week, which is the presentation regarding the encapsulation. So we're going to finish this presentation. What we had a chance to talk about was really just starting here. We started talking about the scope of variables, that we need to realize that there are different scopes of variables, and so variables could be created as part of a class or part of just a local variable, part of the function local scope, or they could be placed in a global scope and just be shared by every part of your program. So the scope of variables obviously is affected by the fact that we can create C++ classes. We also started a project. So let me try to open this project. So we're going to go open project solution, and I think it was named. Let me just see what's on my D drive. In stack. Oh no, it's the old one. Let me just sort this. What did I maybe encapsulation? Maybe was there?
You had made a different CIS 255 folder.
I think it's this one, 9/10/2013. So let me try this one. Let's open this one, because maybe I just named it encapsulation. I may be wrong. We'll see in a second.
That's what I have.
Okay, all right. So if we do open this one, we can just continue on looking at some of this code. So also to remind what we tried, we did some. Okay, so we created the point class, which was directly from our slides. We also tried to work with the class named student, and we had this main program which demonstrated how to instantiate some of these objects. And so if I need to type in some code, I may just try to use that, use this particular area. All right, so we can continue and perhaps use examples. Items that could go inside the class scope. We say that the class declaration, the declaration of the class, opens its own scope of variables. In that scope, we can introduce type defs, enumerations, and other classes. Well, I think we briefly covered that, but those are kind of specialized topics. We're not going to talk about that, and I have examples how to use it. If we need to come back to this, and I'm sure when we start talking about graphics, we will have to deal with some of this, but we're going to perhaps go back to our example and say that in scope of this class point right here, we have two coordinates, two integer variables. And when we say that those two member variables are declared inside class, means that those variables become available instantly to all member functions inside this class. For example, in the implementation of this point class, we had something that says adjust, and we were modifying x and y, which are the coordinates inside the point, and we just said if someone makes a call to this member function adjust and passes a couple of values, what happens is that we're just going to add those values to x and y. But notice that adjust was declared as a member function right here. It gets defined in the implementation file, and inside this implementation we make absolutely no effort to access x and y. We know that what this x and y is. When the main program instantiates a point, well, since we declared those public, we demonstrated that we can access them directly and just set them up. But then here's an example of an adjustment call. So we take an instance of our point variable, which represents an instance of a point class, the actual object, and we say that point adjust, and we pass couple of values, and this function gets invoked, and we instantly get access to our, so x and y become +5 inside here, and then we modify the values of x and y in this particular manner, right? And then of course this arithmetic assignment is the same as just saying this, right? Just saying x plus, right? Or I'm sorry, y plus and x plus, right? So it's the same thing. Arithmetic assignment is just a short version of explicit assignment, just doing the math like this and then assigning the result. Okay, so those things are in place. Just wanted to revisit that. So we said that there are some pitfalls that go with the scopes and nested scopes and make sometimes make things obscure. But I think, again, as we move along with examples, those will surface in many different areas. I'm not going to spend too much time on this particular slide. Something new for today is the static data members. Okay, we can go to our project, and we can say it might be useful for all points, for all objects of class point, if I have my main program and it attempts to instantiate points like PT, PT2, 3, 4, like it create many of these objects. They're all points. But in my design, I might say that this particular class point, could benefit if all of these objects could share common information. For example, I could declare something that on that slide, I guess named, so I can just name things the same way, X origin and Y origin, whatever those things are. So let me do it this way. Int X origin. So it's like the position of the beginning of the system of coordinates or something like that. Because sometimes the system of coordinates itself can be moved around the space. So let's say X and Y. To make X origin and Y origin to be just shared between all objects, what we can do is that we can declare them static. What happens at this point is that if I use some sort of like a picture that I can demonstrate here. So what happens here is that when point is instantiated like this, I can try my drawing skills here and make it look like a 3D box somewhere in memory, just to sort of stress that this is a real thing. It's like a real resources taken away. So inside of this box there's X and Y, right? And if I create multiples of these, right? If I create many points in my main program or elsewhere, right? So I can very easily create a lot of them, and each one of them will have its own set of X's and Y's, right? So it's its own unique variables. But those X origin and Y origin, I want to be able to be shared by all of them. So if I might try something like this to show it on picture. So I want to say X origin, right, and Y origin, those two variables. I want to keep sort of like on to keep these two on the sideline, so that if any of these objects wants to have access to X origin and Y origin, they should be able to do that. And so simply like each one of these objects may decide to go and look up what the origin is, or may be able even to try to update those variables. It should be viewed as basically completely shared information between all these objects. Okay, so what makes it happen is that we say static. Once a variable inside class is declared static, it becomes the same as if those two were declared somewhere here. like in global, in global scope without any restrictions. Like we're made global variables. But instead we say, well, it would be unwise to do something like that from the design standpoint. Instead, what we'd like to do, we'd like to keep those two that they still belong to the class. Check the time here, maybe I can save it.